So we've made a kit in which you can connect a number of systems or devices to this kit, and then identify the status of each and every device which is connected to it. So the main application of this kit is in showrooms or in public places where there are a lot of systems connected to your network, and you need to constantly monitor the status of each and every system. So as you can see, there are a number of switches here. So the particular device, each device is connected to each particular switch. So there are 4 switches. It means there are 4 devices which can be connected. So once you press the switch, the corresponding device identification will be shown on this LCD. So I'll just show you a demo. So as you can see, if we press one switch, the corresponding device is shown here. The status of the device is shown here. So this mainly works on the technology of radio frequency. So we have a RF transmitter here, and we have a RF receiver here, encoder and decoder IC, and a microcontroller which receives the signal and then displays the corresponding output on the LCD screen. So you can order this kit from our website, kitscrew.com, where you'll find 2 versions of the kit. One is where you can receive the entire working kit as shown here in this pic, and the other one is where you will receive the set components separately, and you can assemble those components with the help of our video tutorials on how to assemble those components and how to solder them. In this section of the video, we'll see what all components are used in this kit and how to assemble those components, and how do we assemble all the PCBs, and how do we connect all the PCBs together, and what are the functions of each component. So as you can see, there are basically 2 PCBs. One is the transmitter PCB, the transmitter circuit, and this is the receiver circuit. So we'll start off with the transmitter circuit first. So we have this ready-made kit kept here so that we can identify which component goes where and how the alignment takes place. So in order to assemble this kit, I'll keep my blank PCB in line with the reference PCB so that I can fix all the components accordingly. So this is a blank PCB. Now PCB has 2 layers. This is the top layer where all the components are inserted, and this is the bottom layer where all the tracks are present and the soldering takes place. So the technology that we use is called through-hole technology, in which we drill holes from the top and we solder at the bottom layer. So we'll start off first with the power supply. So as you can see, there's a 2-pin connector base. So the 2-pin connector base goes here. So while connecting, you need to ensure that the red wire is towards the inner side, and then we connect a diode. So this diode is kept as a polarity protector. So in case the power supply is given in the wrong direction, the diode blocks the flow of any current in the circuit to protect the IC. So while connecting the diode, we need to ensure that the negative end is on the left side. As you can see, the strip is on the left side. As you know, the current flows from the positive to negative direction. So the positive end has to be in line with the power supply. And then this is the voltage regulator IC. So the front face, which has specifications written on it, is the front face, and the left pin is the first pin, then common, and then the third pin is the output pin. So while inserting this voltage regulator IC, we need to ensure that the first pin is on the right, which is in line with the negative terminal of the diode. And then we need to insert a resistor of 1 mega ohm with color code brown, black and green before inserting the IC base. So this is the IC base on which the ICs are connected or inserted. We use an IC base so that we can protect the ICs from overheating and getting damaged during the soldering process. And also, in case you need to replace your ICs in the future, we use an IC base. So as you notice that the IC base has a notch here. Even here you can notice that there's a notch. So the notch has to go on the top side, which is away from you. So on this IC base, we'll connect the encoder IC, and then we need to connect a network resistor. A network resistor is a cluster of 8 resistors of 10 kilo ohm each. Now this is inserted to pull up the port 0 of the decoder IC. So as you can see, the network resistor has a dot on the left side. So while inserting this network resistor, we need to ensure that the dot is away from you. So the dot goes away from you, as you can see. And then we connect the switches. So these are 4 switches, DIP switches, which is this has to be connected with the on-off end on the right side, and then we connect the transmitter. So when you look at the transmitter, at the back side you will see the identifications. So the end which has antenna written on it, ANT, goes closer to this antenna wire. As you can see, this is the antenna wire. So the antenna terminal or the antenna port goes nearer to the antenna wire. So this is how this transmitter circuit is connected. And you also have to make sure that you keep soldering the components as you go on fixing or inserting the components. So the next we move on to the main PCB or the receiver PCB. So this receiver PCB has mainly 3 sections. One is the section of the power supply, the second is the section of the receiver, which has a microcontroller and the decoder IC in it, and the third is the section of the LCD. So we'll start off with the power supply. So first we have a power jack. Then there is a bridge rectifier. So a bridge rectifier converts the AC input into a DC output. So when you look at the bridge rectifier, you'll notice that there are 4 terminals, 2 AC inputs and 2 DC outputs indicated by positive and negative sign. And you'll notice that the terminal corresponding to the positive terminal has the longest stem in it. So while inserting the bridge rectifier, we'll ensure that the positive terminal is on the top right side. So this is bridge rectifier is used in case you're giving an input through a transformer. Then we use an electrolytic capacitor of 1000 microfarad. So even this has polarity. So the stem which is longer in length is the positive terminal. And if the stems are of equal length, you'll notice that there is a blue strip on the capacitor which indicates that that is a negative terminal. So while inserting the capacitor, we need to ensure that the positive terminal is in line with the positive terminal of the bridge rectifier. So you will be facing the negative terminal and the positive will be away from you. Then we insert a switch, on-off switch. And then we insert this voltage regulator IC because all the components work at 5 volts. So we insert the voltage regulator IC in order to convert the input power to 5 volts smooth output. So while inserting the voltage regulator IC, we need to ensure that the first pin is away from you so that it is in line with the positive terminal of the bridge rectifier. Then we insert an LED. So even LED has 2 terminals. So as you can see, there are 2 LEDs. So this is the LED for the power indicator, and the other LED is for the indication that the system or the PCB is receiving the signals from the transmitter. So LED has 2 terminals, a positive and negative terminal. The port which is, or the stem which is longer in length, is a positive terminal. In case the stems are of equal length, you'll notice that the bulb gets flat at particular portion. So that flat end of the bulb indicates that is a negative terminal. So while inserting the LED, we need to ensure that the negative terminal is on the right side. And to protect the LED, we insert a resistor of 1K with color code brown, black and red. And then we move on to the decoder IC. Now before inserting the decoder IC, we connect the IC base. So even here the notch will be away from you. As you can see, there's this notch. So the notch is away from you. And along with that, we'll insert a resistor of 51K. So this has a color code of green, brown and orange. Then we'll insert 4 resistors of 10K with color code brown, black and orange. So this is to pull up the port 0 of the microcontroller. We insert the resistors first so that we can insert the ICs easily. So this is the main microcontroller and a 40-pin 8051 microcontroller. So the notch is on the right side, as you can see. This is notch. So while inserting the IC base, we need to ensure that the notch is on the right side. The microcontroller runs on a clock frequency, so which is generated by a 10 MHz crystal oscillator. And in order to start the oscillation process, we connect 2 capacitors of 33 picofarad each, connected parallel to each other. Then we connect a micro switch to reset the microcontroller. And to pull down this micro switch, we connect another resistor of 10K, color code brown, black and orange. You need to notice and ensure that the color codes are proper. And then there is another LED, which is a power indicator. So while inserting this also, we need to ensure that the negative terminal is on the right side. And the protector resistor 1K. Then we can insert a potentiometer to control the brightness or the display of the LCD display. And then we insert a male bus strip. So this is the male bus strip which goes inside this slot, and the female bus strip has to be inserted into the LCD, and then it has to be inserted onto the mounted onto the male bus strip. And then we insert this receiver. So as you can see, this is the antenna wire. So when you look at the receiver, the rear end of the receiver, you will notice that the antenna terminal is on the right side here. So that antenna terminal goes near the antenna wire. So after finishing the connections and before inserting all the microcontrollers and the ICs, we need to ensure that the power supplies are okay. So first we'll connect the transmitter circuit to the battery. Make sure that the battery is new and it is charged. So first we'll check the power supply at the transmitter circuit. So we do that using a digital multimeter. So this is the digital multimeter. The black terminal is connected to the body of the voltage regulator IC, and then the output, that is the third stem of the voltage regulator IC, should show 5 volts. So this is okay. And then at the receiver circuit, the first stem should show the input power supply, and the third should show the (5 volts) output supply. The last pin of the decoder IC should show 5 volts. The last pin of the microcontroller should show 5 volts. That is the 40th pin. So you need to make sure that you know the pin numbers and how to count the pin numbers. So I'll tell you. The pin which is on the top right, which is on the left side of the notch, is the pin number 1, and then you have to count counterclockwise. So the pin which is below the notch is pin number 40, and the second last terminal of the LCD should show 5 volts. So once this power supply is connected and checked, we can continue with the connecting our ICs and complete the kit. So you can order this kit from our website kitscrew.com, where you'll find 2 versions of the kit. One is where you'll get this ready-made kit, and the other one where you'll get all the components separately, which can be assembled using our video tutorials on how to assemble the kit and how to solder them.